It's not complete. Yeah. Okay, so just recap. Our chemistry 2 will have 8 chapters. We already covered chapter 1, chapter 2. Now we go to chapter 3. We'll deal with intermolecular forces. We focus on liquid and solid. Yeah? Focus on liquid and solid. Gases, we're already done with the PV equal to nRT. Now we look at intermolecular forces. Yeah. Okay. So in this chapter, we'll look at property of liquid and solid. We'll look at into how the intermolecular forces act, especially surface tension. We'll look at viscosity, and in your test, you'll be asked what is the London laws or dispersion law, dipole, hydrogen bonding, and ion dipole. So in chapter 1, you already been exposed to how to identify its covalent bond, ionic bond, and so on by looking at the periodic table. Now we look at covalent bonding, specifically in these 3 types: dispersion, dipole, hydrogen bonding, and ion dipole bonding. And we look at crystalline solidity. Okay. This phenomena you will see when there's a droplet drop on the water. Right? So let's see. Look. So you'll see there's a ripple, and you see a form of pillar in a slow-mo video. So we explain this phenomena, why you see this kind of phenomena. Why when you drop something on water, you will see there's a pillar come out, yeah? So we want to explain this phenomena. Okay. So this phenomena happen because of intermolecular forces. Right? What is intermolecular forces? It's attractive forces among the particle. Okay. So we start to look into the effect of intermolecular forces. It is attractive forces that exist among the particles. All right. So what the state of matter, basically, it depends on the magnitude. How big is the intermolecular forces and the energy given or stored inside the element. There are 2 things. The state of the metals, either it can form in gases, solid or liquid. It depends on 2 factors. One is intermolecular forces magnitude and the thermal energy in the sample. Okay. So here is just an illustration. The blue dot is atoms, plus minus is the ion. So if you add heat, the solid will combine together, the intermolecular forces will stay together until a certain stage of the heat. It will break the bonding between the line and all the atoms will drop and it will form liquid. And if you add heat, it will start vibrate, and there will be they will hit each other, and there's a space between the gas. And if we give additional heat to the gases, the molecular will break into ion. The rest you read. So if you something that related to thermal energy means it related to temperature lah. Okay. the relationship between intermolecular forces and thermal energy. If you have stronger magnitude of intermolecular forces relative to thermal energy, means you have stronger connection between atom and atom compared to the energy given, then most likely it will be in the liquid or solid, right? So the chapter 2, we deal with gases. Now we deal with liquid and solid. Okay, now we look at liquid properties and solid. This one you already done in chemistry 1. This is just a recap. So this is some illustration of gas, liquid, and solid. So basically, if we look at gases, basically they are separate the atoms. We look at atoms, the distance will be very large, all right? And liquid solids are close contact. So if the question asks you the properties of liquid and solid, these are the point you write lah. First, you talking about distance between atoms. First properties, you need to elaborate. First point we are looking for is the distance between atoms. Gases is very large, while for the liquid and solids, they are very close. Okay. First point for properties of gas, liquid, and solid is we discuss from the distance between atom or molecule. Second point is a freedom of movement. Freedom of movement. So as you can see here, solid, they do not have freedom to move. However, in liquid, they able to move around, but they are in the close contact, right? Yeah, gases, you know that they are free to move around. So for liquid and solid, the difference between liquid solid, the molecule are in fixed position. Now we deal with two parameters. One is the intermolecular forces and thermal energy. Now we start to look at properties of liquid and solid. So the first one just now is the distance between atom and molecule. Second one is the freedom of movement, right? You talk about freedom of movement. Okay, so these are the summary of the liquid and solid. So this one you can read. So later you can have a view on this one in your revision time. So in test, maybe you'll be asked in question section A, the theory part, you ask you, give 3 properties for liquid and solid. So you need to give 3 points for liquid, 3 points for solid. This one you write lah, huh? So first, liquid is density high compared to gases. You talk about density. Second, you talk about shape. Third one, you talk about volume. Okay. D-finite means you are unable to define because it's open to space. You are unable to contain the gases, right? So solid, high density compared to gases. You take gas as a comparison. Then you have in defined shape, and you do not take the shape of the container. Define volume and crystalline, right, or amorphous. So this table will summarize all the properties of gas and liquid. Talk about density, shape, volume, strength of intermolecular forces. This one is important for chapter 3, right? So gases will be weak, liquid will be moderate, solid will be strong. Okay, so this is illustration. This is a very a short quiz. So a substance have defined shape and volume. Define shape and volume. What is the state of this substance? solid. Okay. Now we go into the major section of one of the major section of chapter 3. We start to look into intermolecular forces. Okay. Okay, without the intermolecular forces, you don't have solid state and liquid state. Okay, that's why we, in chapter 3, will focus, because it's main focus on intermolecular forces. Basically, we focus on liquid and solid. Manifestation of intermolecular forces will be surface tension and viscosity. So manifestation means your observation or the behavior of that particular substance. In this case, liquid. You will see surface tension and viscosity. So this is just if you go fishing, this is one of kind of the bait that can float on water. So this one will mimic insect. You just throw the bait, and this bait will float on water, and you wind the fishing rod. This one will be like an insect drop on water, and you will move on water. So the fish will take this one as an insect. It will go and bite the bait. So this one using the principle of surface tension. So this one go into designs already, product design, right? So if you go into material science or go into aerospace design later, you might be given a project to design some devices that float on water. Okay. Right. Now, why do this bait can float on water? It's because of surface tension and the tendency of liquid to minimize their surface area. So it's just that if you have minimum surface area that touch the surface, then it will float. Okay. All right. This one just this one you read. I think. Okay. To explain what is surface tension, you explain through the behavior of liquid what the liquid tends to do. To explain the surface tension, the liquid tends to minimize the number of molecules at the surface. That will create surface tension. If you done your experiment, you will try to put a paper clip on the water. So if the paper clip able to float, it's because the liquid tends to minimize the number of molecules on the surface, especially around the contact surface between the paper clip and the water surface. Okay. However, if you drop a drop of gasoline or soap, you drop a soap, you cannot hold this paper clip because you already generate the intermolecular forces among molecule in the gasoline will be weaker. So it means not drop. Just now I mentioned the word drop is not drop. You cannot do the same thing on a container that contain 100% of gasoline. You cannot. This paper clip cannot float on the gasoline. Okay. Because the intermolecular forces of the gasoline is weaker than the water. And of course, you can drop something solution on the surface water, and like for example soap, it will also drop the thing because it destroys the intermolecular forces. Yeah. Okay. Okay, so by now you should be able to explain what is surface tension. Surface tension is because the liquid tends to minimize the number of molecules at the surface. Okay. So this one you already seen that what is surface tension just now. Maybe I'll let you watch a bit.
You know you wanna new body badalada lotion. 24 hours of weightless daily hydration. You know you wanna new body badalada lotion.
By looking into the invisible world of high speed, we discover extraordinary events, even
Some
in
insects,
something
they
as
can float
ordinary
in water.
as a garden pond.
These little creatures, water striders, had long been a bit of a mystery. Nobody could work out quite how they could propel themselves across the surface of the water so quickly.
They can scoot forward nearly 2 meters every second. And they're achieving something of biblical proportions, actually walking on water, skating across the surface without sinking.
Only by seeing what time usually renders invisible to us can we understand what's really going on. And it's got something to do with what's about to happen here.
Normally, this is too fast to see. But watch what happens in slow motion as the droplet of milk hits the water surface.
It's a milk molecule.
Instead of breaking, the water surface stretches, bouncing the milk drop back up into the air.
The rest you watch now. Okay. Just now we look at surface tension. Now we look at viscosity. What is viscosity? Definition for viscosity is resistant a liquid to flow. Right? So if you say the liquid is more viscous, then they flow slower. More viscous means more slower. Motor oil more viscous than gasoline. Syrup more viscous than water. Okay, so you see, if you use the word more viscous, means it flows slower. Right. So if you have a greater viscosity, means you have a stronger intermolecular forces. Now we keep mentioning the intermolecular forces, yeah? So intermolecular forces, just now we mentioned surface tension. Now we look into viscosity. For example, in your chapter 8, later we look in hydrocarbon. So long molecules such as hydrocarbon tends to form viscous liquid because they have a long chain, molecular entanglement. I would call it long chain. motor oil, they are more viscous compared to other substance because of the structure, molecule structure, long molecule or long chain. Yeah. So since we are studying foundation in science and very high chances you go into engineering later, you should be able to know what is meant by the motor oil, the code and so on, right? But this one I'll let you go to watch this video when you have free, right? But what is important, it tell you the viscosity between the engine oil. Okay, I want to ask you about engine oil in this module. Okay, all right. Next, we revisit the concept of evaporation and condensation. This one you learn in your SPM chemistry and chemistry 1, right? So you can observe when you have a cup of water, you put it by the side of the window and you left it for a few days, the water level will drop. It's because of evaporation, condensation, right? Evaporation. Right? Okay. Now, how this phenomena happen? It starts from at the surface, water molecule have fewer attraction, then it will break away from the liquid, right? So it starts from the surface. The molecule escape from the surface because at the surface they have fewer attraction. Number 2, in the liquid have distribution of kinetic energy at any given temperature. So because the energy is distributed between the liquid, okay. Now sometimes in tests or final exam, they'll ask you to explain a phenomena using the understanding of evaporation and condensation. So you need to tell me what actually happened at the surface, at the molecule level, what happened to the energy. These are the two things. You need to use what happened at the surface. You need to look at the molecule at the surface, and then what happened to the energy. Yeah. Okay. Just explain why the water level can drop if you leave the water or the substance at a certain condition. This is the keyword. Molecule at surface are less held tightly than those in interior. And the more energetic one will break away. Talk about energy. So there are two phenomena, which is evaporation and vaporization. Okay. So these two processes will change liquid into gases. So you need to understand what is evaporation and vaporization. Just a revisit. This concept we already know already. Okay. So these are the factors. This is chemistry 2 kind of question. It won't ask you definition of evaporation, but it will ask you what affect the process. These three factors. What will cause the evaporation rate? What will affect the evaporation rate? If you increase the surface area, means more molecule exposed to the surface, right? Then more molecule escape. So you increase the surface area. Second one, you increase the temperature, you give more energy, then more energy will give energy for the molecule at surface to escape. Then you also, because of the energy or temperature, you break the strength of the intermolecular forces. Means this one, you play with surface area, temperature, and intermolecular forces. It depends how question asks you. The slide that you see here, it asks you the rate how you increase the rate. Increase the rate, you increase the surface area. you increase the temperature, you decrease the magnitude of the intermolecular forces. Of course, you can foresee what are the test question will ask you. What factor or how you decrease the rate of vaporization? You need to reverse all this. Just to test your understanding. All right. This is how we set the question, just to test your understanding. We do understand what actually affect the rate. So in chemistry 2 question, we won't ask you directly from the PowerPoint slides. Yeah, we'll ask you, do you learn something from the slides? Okay, so just prepare. If the question asks you, what can affect the rate of vaporization? What can decrease the rate of vaporization? So you need to reverse all this. Yeah, rate of vaporization decrease when you decrease the surface area, when you decrease the temperature, and you increase the strength of intermolecular force. Okay, so this is another technical word, volatile. So if the substance or liquid that can evaporate easily, we call it is volatile. Though they're not easily, we call it non-volatile, right? Okay, so sometimes the question will, in the section C question, or the third section of question will ask you why, or which liquid or which surface will be more volatile. Okay, and the rest is just give you an example. Okay, all right. So in the test, this will be the expected answer. Of course, the question you need to verify with some calculation. For example, the area you can calculate, temperature you can predict, intermolecular force you can also predict. In chapter 1, the only table give you the orientation of the molecule and so on. All right. So you have 3 kind of forces: ionic, covalent, these 2, and also metal. Okay. All right. So this is just to start to look at evaporation. Now, this scenario, what happened? What is different from this slide to the previous slides? If you observe the diagram, now the container was blocked on the top of the container, right? So evaporation will start to happen if you have enough energy, right? So it will continue to happen, but then condensation will also start to happen. So we need to break these 2 words, evaporation and condensation, into equation. Right? This one you read. It bounce off, molecule bounce off a wall and so on. Okay. So this is the definition of condensation in the textbook context. So condensation is a physical change where it changes from gas to liquid. This is a SPM level of definition. Okay, condensation is gas into liquid state. Evaporation is the reverse. Evaporation is gas into liquid. Sorry. Evaporation is liquid to gas. Condensation is gas to liquid. Okay, these 2 are. How you explain this one is from the state of the substance. Usually, If you want to give you free marks, this one will be in the section A of the question. Just to give you some free mark or easy mark to score. Just to ask you to give definition of a certain word. Okay. All right, so this more technical. When does the time when these two become equivalent, means it will stop? The rate of condensation and the rate of evaporation will be equal when the condition is called dynamic equivalent. This is chemistry 2 content, where we talk about rate of condensation and rate of evaporation. When does these two conditions will be equal to each other? When you reach a dynamic equilibrium. What is dynamic equilibrium? Is when the number of gas of water molecule above the liquid remain constant. In this case, if you look at the diagram, the volume must be constant. Means it's a closed container. Okay. Dynamic equilibrium. So if sometimes you are lazy to write in the test, also you can write the equation. You can just write dynamic equivalent, fulfill the following equation. You can just write rate of evaporation equal to rate of condensation. Okay. So in this module, I don't test your grammar, I don't test your English, as long as you give me the correct keyword and the expected answer or equation, then you can get marks already. Okay. Okay. We start to revisit what is vapor pressure. Vapor pressure. Vapor pressure of liquid is partial pressure in its vapor form in dynamic equilibrium with its liquid. This one we go deeper a little bit. Just now in chapter 2, we saw this vapor pressure by using a table. But now chapter 3, we go into a bit technical a bit. So at water, if you refer to the table just now, at 298, the pressure is 3.17 kilopascal, which is also we proved by the calculation. This table, right? So 298, water pressure, vapor pressure is 3.17 kilopascal. Okay. So these are the things that is important, these 2 points. Vapor pressure increase with 2 factors. One is temperature, one is intermolecular forces. Which is again back to the first slide just now. We are talking about energy and intermolecular forces. All right, thermal energy. Thermal energy, in other words, is temperature. So basically, the whole chapter 3 linked with these 2 words lah. Intermolecular forces and temperature. Okay. You want to increase the vapor pressure, increase temperature, decrease or reduce the strength of intermolecular forces. So you should be able to answer, how do we decrease the vapor pressure? You decrease temperature, you increase intermolecular forces. Something like that. Okay. All right. One highlight here, don't confuse with surface area. Vapor pressure is independent, means it do not affect by surface area. Sometimes the test question will purposely trick you. It will ask you, it will say something like surface area increase, what happened to the vapor pressure? Something like that. Then the answer is, you need to give the answer, vapor pressure is independent of the surface area. Or the surface area do not affect vapor pressure. Sometimes we purposely trick you to, we give you a lot of information, we give you some table just to confuse you, then we probably ask you something else. So this, the highlight, if you see in my slide, I highlight in red one, you need to be careful a bit. High chances I put something in the test or final exam. Right? Okay. Okay, boiling, you know, boiling, what is boiling? Okay, boiling point. What is boiling point? Is the temperature. Temperature when the vapor pressure is equal to pressure above it. Okay, this is the answer for chemistry 2. Boiling point, you have able to answer what is boiling point. Okay. So boiling point is vapor pressure will equal to the pressure above. This is a pressure above. So boiling point, basically we refer to the temperature linked to pressure. So why can you see the boiling phenomena is because of the energy again. Thermal energy is enough to break free into gas phases. Okay. Make very fast. Water, you know, is 373 Kelvin. In this module, chemistry 2, we use temperature, we use Kelvin unit in all calculation. Of course, in tests, you won't see water in a question. We'll use other substance. That's for info. Okay, the rest is just phenomena you see when you boil water because of some bubbles, gases. Why got bubble? Because got gas inside the water, right? And so on. Okay. At a certain stage, if you increase the temperature, the liquid, it doesn't raise the temperature of the liquid above its boiling point. So the maximum temperature of the liquid is the boiling point temperature. Okay. Talk about liquid. So the question might ask you something, a statement, then you explain. This is about liquid. It asks you something, it asks you temperature. Temperature of the liquid. Maximum, it asks you maximum liquid of a maximum temperature for that liquid can reach. Sometimes I give you a boiling point table. You straight away you read from a table and give me the answer. Okay. So this slide is actually for the question to ask you maximum temperature of a liquid. It asks you liquid. So you look at the boiling point table. Boiling point will link with pressure. Pressure will link with altitudes. Okay, so this is a chart that you're already familiar with, especially water. So when you study engineering material later on, you will see water, if you heat from 293, 273, 0 degree, then you add, it will increase, and then it will stop. It will maintain at 100 degrees C or 373 Kelvin. Then after certain times, when the liquid convert into gas, then the temperature will increase again. Right? So what happened to the left-hand side of the straight line here will be this, from this point to this point will be solid state. Here to here will be solid state. Here to here will be liquid. Here to here will be gas. Okay, this one you already know. The rest you read. This is just a quick question. The gas over a rapid boiling pot. Boiling, you see the word boiling basically asks you about pressure, asks about you the maximum temperature, and so on. Is sampled and analyzed. Which substance compose the larger fraction of gas sample? H2, H2O, O2, or H2O2. This one linked to your understanding in molecule. Okay, this one you go home and think about it. Okay. Next, we want to look at evaporation. Okay. In chapter 3 onwards, you need to use the word endothermic. Endothermic means it receives or absorbs heat. Endothermic. In later chapter, you will see equation in stoichiometric. You need to explain whether it is an endothermic process or exothermic process. So first, evaporation is endothermic process because the energy is required you absorb energy to break the intermolecular forces. You change the state lah. Okay. The rest you read. Important is this line, this statement. Evaporation is endothermic, and then you must understand what is endothermic word. The word meaning is it absorbs heat. The absorbed heat is linked to endothermic. Okay. Our bodies use endothermic for evaporation for cooling. So if we overheat, we sweat. Why we sweat? Because we use sweat to start the endothermic process. Yeah. So sometimes the question will ask you a scenario. It asks you to explain the evaporation and condensation process. So basically, if you see question to explain evaporation or condensation, we're actually looking for endothermic or exothermic, this keyword in your answer. Okay, another one, condensation. Condensation is exothermic. Exothermic, exo means you release, you give. Endo, you receive. Exo, you release. Endo, you receive. Exo, you give out. So two technical word, endothermic, exothermic. Okay, later you will see delta H. Delta H, it will refer to the magnitude of heat. Later you see positive value and you see negative value. Okay, so this experiment setup is already done before in your SPM, right? You boil water and then you condense water. How you condense water? There is a mechanism here. You pump in cool water and there's a warm water come out from another end. So when hot gas pass through this mechanism, condensation, here, gaseous state will change to liquid state. Okay. In your experiment, you use this process. Of course, we won't use water. We'll use another substance, maybe for your hydrocarbon experiment. Okay. Okay. So this is just to explain how people get burned from the steam burn, especially those work in the kitchen. Why you can burn? Because the energy released into your hand. Some application. So in this is overseas. If you have city near the coastal cities, you will see exothermic process happen in the nature. So these are the two lah. So this one, if you're near to the coastal, will tends to have water vapor in the air. So you'll see some mist lah during winter time. You see some blur image or some condensation. In desert, you have dry air. You have clear vision during the night. Which temperature is lower and why? The difference here is the content of water. Yeah. Right? So as the air temperature in the coastal city drops, water condense. When water condense, it release heat. Why it release heat? You need to change from liquid state from gases into liquid. Right? So they will prevent the temperature from dropping further. So this one is happen in the coastal city. So when the air temperature drops, the water in the air will condense out of the air to releasing heat and preventing the temperature from drop further. So when you have water condense and release heat, what happened to the temperature? The temperature will increase. So we'll feel warm in the winter city area near to the coast. You feel warm because the water condense out of air and releasing heat to the environment. Okay. In desert, there's not enough moisture, so the temperature will drop faster. So it's very dangerous if you're exposed to desert. You will freeze to death sometime. Right? Yeah. Okay, we start to look at delta H vaporization. Heat of vaporization is amount of heat or quantity of heat that required to vaporize 1 mole. The keyword here is 1 mole. Again, back to PV equal to nRT. 1 mole equal to the molecular weight of that particular compound. Yeah? So H2O is basically H2O is 18 gram, 18 point something gram, right? So water, heat of vaporization of delta H VAP. So in your test, if you're asked to answer looking for answer for heat of vaporization, in your calculation, you need to write delta H sub VAP. If you do not write VAP, I will assume I put a question mark, what kind of heat that you are referring to. Unless you write heat of vaporization, bracket delta H, close bracket, then I know you're referring to heat of vaporization. And if later, after heat of evaporation, you will look at condensation, right? So if you do not write correctly your answer, you forget about the sub. If both you give me delta H, I'll put both question marks. Again, for the test of final exam, if you give me chances to choose answer for you, I'll choose the wrong answer. Don't expect me to choose the correct answer for you. Huh? Okay. All right. So this is the way you write in a certain molecular equation. Something plus something give you, through the process, give you C and D or give you another products. You write in certain way. And if the question you see delta H something, it means something. Huh? It means something. So if you see a positive, it's a vaporization. Okay? Means you give energy. Positive means you give energy. Huh? This is the way you write in chemistry terms. Huh? You write the process, stoichiometric reaction, then you write the delta H equal to something. And the temperature is important. Huh? You need to prove your answer that this is endothermic in the test or final exam. Your answer, your calculation, at the end, arrive at positive value. The process is endothermic. So the process is vaporization. This is how you prove your answers in chemistry 2 question. Okay. I cannot say, you cannot just simply say it's endothermic without proving your answer in test. You need to give me some calculation. In the end, you get, for example, this example, you get positive value. Then this is, then you write delta H is positive. It's positive because it's endothermic and this is a vaporization process. So energy must be added to the water to vaporize. Okay, endo means receive. Huh? So if it's the same substance, for example, if your vaporization is 40.7 kilojoule per mole, condensation will be the same. Huh? The magnitude will be the same. Huh? Magnitude of that heat will be the same. So in this module, positive value and negative value mean something. If you do not write something in front of the number, I assume it's positive. If you do not, yeah. So if you put it as nothing, no sign in front of the value, I'll assume as positive, and I'll assume your answer will be endothermic. So if the question is exothermic, you forget about the negative sign, I assume it's a wrong answer. Yeah. So this is how you write the answer for chemistry 2. So this is how you prove like a standard state, standard form. So you arrive at calculation, negative sign, something. Then you say that based on calculation, the delta H is negative. So it's endothermic. And this process is condensation. Right? Energy is given off when it's condensed. Yeah. So heat of vaporization, positive, negative sign is important. So endo is positive, delta H positive. Exo is negative. Huh? So this is a table that you see. Of course, this is just one part of the table. So given a certain substance, chemical formula, normal boiling point, heat of vaporization at boiling point, heat of vaporization at 25 degrees C. There are two different columns. You need to see what the question asks you. Sometimes the question will ask you at 25 degrees C. The statement will give you in 25 degrees C, but the final answer will ask you at boiling point. This H, delta H here is different. A different temperature, different heat of vaporization. Just need to take note. In this table, there are two different columns. One is 25 degrees C, one is at boiling point. And I already defined boiling point definition just now. Boiling point depends on the pressure, vapor, and the pressure above the liquid. This is the definition of boiling point just now. Okay, so this is just a highlight. Just a highlight. So heat of vaporization, they depend on the temperature. So if you change the temperature, the vaporization will be different. So you see, if water, when you reach boiling point, the delta H is 40.7. However, heat of vaporization at 25 degrees C for water is a bit higher compared to boiling point. Why? Because at boiling point, you already have enough energy. You only need a little bit push to push the molecule from surface into the space outside the surface. Okay. All right. So the rest you read. This is where we set the question. You can use the heat of vaporization liquid to calculate amount of energy required to vaporize. A given amount, this one already know how to find. Given amount, this one you calculate in mole. Then from mole, you calculate into gram. Or gram or volume. Okay. So you know liquid, liquid and gas a bit different. How to find volume of liquid? You need to use density. You need to use density to find. Density multiplied by the volume of the container. Sorry, not volume of liquid. It's the amount. Sorry, amount here. Amount of liquid means this one can be N, can be gram. So you multiply by volume. Density multiplied by volume, you get a gram. So from gram, you divide by the atomic number, molar atomic number, you get number of mole. So this is just another statement. So it just heat vaporization. It's just to tell you, you can do this one as conversion factor between mole and the amount of heat to vaporize. You see the unit in the table is kilojoule over mole. Kilojoule over mole means if you're given a certain gram of substance, you need to convert that certain gram of substance into mole, multiply this number, you get amount of heat you need to convert. Okay, right. So let's just give an example, then we go for a short break. Okay, calculate the amount of heat required to vaporize 2.5 grams of water. So in your tutorial question there, they are given a table. So you need to calculate the delta H vaporized 25 gram of water. So 25 gram of water got how many mole got how many mole? If you have 25 gram of water, you know that 1 mole got how many in H2O? Water is H2O. H is 1 gram, multiply 2 hydrogen. Oxygen is 16 point something, right? You refer to chapter 1 periodic table, you arrive at 18 point something something gram, right? So you need to use 18 point something something, 3 digit at the back, to divide the 25.0 gram. Okay. So from the table, it's 14.7 kilojoule per mole at 373. Because it's sent here is boiling point. So there are 2 columns in the table. One is boiling point, one is 25 degrees C. You need to look at boiling point column. So for water is 14.7 kilojoule over mole. So 1 mole you get 18.2 gram. This one you calculate from the periodic table. Okay. Now for test, you won't see water, just for info. You'll be given some compound with a bracket of equation, molecular equation. Let's say CH4, C4H6 and something. You need to know how to calculate that. Huh? Okay. So you take 25 gram divided by 18.2 gram H2O. You get 1.378 mole. Then you have the vaporization value, certain kilojoule per mole. You multiply this one, this value, you get kilojoule. And maybe in test will be additional information. A certain kilojoule will increase the temperature 1 degree C. So you ask you the temperature, will it change or not, and so on. Okay. So you again, you need to show me your steps. You need to show me the steps. Oh, sorry, I canceled the wrong position. I should be canceling the gram and not the H2O. I should be canceling the blue slash should be on the gram and not H2O. Position error in my slides. Yeah. Answer for this tutorial question is 56.50 something kilojoule. Give me 3 decimal place in your answer. So this one is the tutorial question. Okay. Then we stop here. This one this one you do when you do revision, you stop here. 10 minutes enough, 10 minutes. Okay, 110, we continue. 10 minutes breaks.